In figures 8.6 and 8.7, we're going to revisit the concepts of pass by value and pass by reference that were first introduced back in Lesson 5. Now we're going to start by taking a look at a simple pass by value example. Then we're going to revisit pass by reference, but this time we're going to use pointers to implement pass by reference. So let's take a look at this simple cube example first, where we're going to cube an integer value by passing it into a function by value. So you can see here that we have a prototype for a cube by value function that takes an integer and returns an integer. The definition of that function is down here after main, where we receive the integer n and return n times n times n as an integer. So in main, we've declared the integer variable number and initialized it to 5. We display for you the initial value of that variable, and then we call cube by value. Now, when you pass an argument by value, the only way you could modify that variable back in the caller, which is main in this case, is if you take the value that's returned and assign it back to the original variable in memory, and that's what we're doing here. So cube by value with the argument number is going to take the value of variable number, make a copy of it. That copy will be passed to cube by value. Cube by value will do the calculation and return the result, and the result will then be assigned to the variable number and displayed here at line 16. So if we just run this program quickly, we can see that the cube of the value is 125. And separately, if we run this in the debugger, let's just put a breakpoint in here and run the program. If we run this in the debugger, that we can see here that number is 5. If we step into the cube by value function and step through it, we can see as we return that the return value from cube by value is 125. Number is still 5 right now, so we have proof that the variable number has not yet been modified, even though the function has already returned. And then if I step once again, we can see that now number's value has been changed to 125. So again, with pass by value, a copy gets made. The function that gets called cannot modify the original value unless the caller takes a return value and physically modifies that variable in memory, which is what we did here. Now, what we'd like to do next is take a look at another version of this same program, this time using pass by reference, and it's from figure 8.7. And here you can see the function that, let's stop debugging as well. Here we can see the actual function called cube by reference, and in this case it says that it receives a pointer to an integer. Now, a pointer to an integer is the location of some integer variable in memory, and when you give a function access to the variable's address in memory, the function can go to that address and do things to the value. It can modify the value in particular. You can see here that this function returns void, so any changes that we see in main in this example are being applied inside the cube by reference function. So let me go ahead and run this first so that we can see that indeed it modifies a value. The original value is 5, the new value is 125, and if you take a look at our source code here, you can see in main that once again we declare the integer called number and assign it 5. We display its original value, and then we call cube by reference, passing not the variable number but the address of the variable number. The address of a variable is a pointer to that variable. So we're telling cube by reference, go to that location in memory to see the value that you'll be manipulating. Now, cube by reference receives as its argument a variable which we're calling nptr, which is a pointer to an integer. It must receive an address as its argument. And in the body, we have this somewhat more complex expression that we're evaluating, where in order to access npointer's value that it points to, we have to dereference that pointer. So star nptr gives me the value of the variable that nptr points to, and the value of that variable is the value of the variable number 5, which is 5. So this highlighted expression gives me the value 5, this highlighted expression gives me the value 5, and this highlighted expression gives me the value 5. So I have 5 times 5 times 5 as the right-hand side of this assignment. And then what we're saying is go place into the location in memory that NPTR points to, place into that location the value that's calculated on the right side of the assignment. So basically what we're saying is go modify the value of the variable that NPTR points to. Notice we say star NPTR here. We don't want to modify the address that's stored in NPTR. We want to go to where the NPTR points and modify the value of that variable. So by doing that, basically star NPTR is an alias for the variable number in memory, and anything we do to star NPTR affects the variable number's value in memory. So to show you how this one works, let's go ahead and set a breakpoint and run the program once again. And you can see that initially number has not been initialized. So let's step over, and now number has the value 5. Now we're going to output the value of number, which is of course 5, and now we're about to jump into cube by reference. So I'm going to step into that function, and you can see that we're now inside of that function. NPTR has an address that it's been initialized to, and if I expand this, we can see that it's indirectly pointing to the value 5 in memory, and the value 5 is actually the variable number's value. Now if I step into the body of this function, I can see that star NPTR is the value 5, so I know that I'm going to get 5 times 5 times 5 for a total of 125. And in fact, if I highlight that entire expression and hover over it, you can see that it's calculating the value 125 in the quick info box that appears. That value is then going to be stored in whatever NPTR points to. So if I step over that, I can now see that star NPTR is the value 125. And as I return back to the caller, now we're back in main, having finished this call to cube by reference, and we can see already that number has the value 125, even though I did not assign any new values to that variable inside this main function. So now that we've completed that, we can step over, and of course now we would display the value 125. And to just demonstrate one more time, let me stop the debugger and run this from scratch, and you can see that of course again the value is indeed 125. So here what we've been focusing on is the difference between call by value versus call by reference implemented with pointers and memory addresses. And you can see one key difference between how we did pass by reference previously and how we're doing it here. When we do pass by reference with reference parameters, you simply specify the variable name when you pass it into a function, and then behind the scenes C++ takes care of all of the pointer stuff that needs to be done to create this concept called a reference. And underneath the hood, references are basically pointers, but we never see the address operator, the dereferencing operator when working with a reference. On the other hand, when you're dealing with pointers, you must specify the address of a variable in order to get a pointer to that variable to be passed into a given function that expects to receive a pointer. Now from this point forward, of course, in this lesson we'll be focusing on how to use pointers, and as we proceed further along into later lessons and get into some of the object-oriented programming concepts, we'll show you that many things can be done both with pointers and with references, and we'll talk about the differences between the two and when you should try to use one versus another, and also cases where you have to use one versus another as well.